Very good morning, students. Welcome to the SBR online classes. Here we are dealing with the integrals chapter here. So in yesterday we finished two exercises of the integration there. So now we are going to discuss about the next substitution method of the integration, that is integration by using trigonometric identities. Okay. Now you have come across the two exercises there. You know now the simple integrable forms, and the second one is there are the integrands which can be transformed into the simple integrable by using substitution there. Now we are going to study about the some of the integrands which are more complex than the substitution method there. So here here these integrands will be transformed into simple integrable format by using what are trigonometric identities. So after transforming the complex integrands as a simple integrands, so those simple integrands may be of the substitution method or to easily integral forms there, right? So in that manner, we have to transform the integrands to get the easily integrable forms. So here we need trigonometric identities, right, to know and to apply in the complex integrals there, right, in the complex forms of integrals. So what are the formulas you have to remember to apply in the integrals there? So just see here. You note down all these things in the last page of your book there, right? Why? Because it will be helpful to find out the integrals. So first thing you need is like this. Sine of minus theta is minus sine theta, right? Cos of minus theta is plus cos theta, right? So what is sine 2 theta formula, students? What is sine 2 theta? Sine theta is 2 sine theta cos theta, right? So what is sine 3 theta? 3 sine theta minus 4 sine cube theta, right? So you can convert in the half angles also. You can convert in the half angles also. How do you write sine theta in the half angles? It can be written as sine 2 sine theta by 2 cos theta by 2, right? This sine 2 theta you can convert in the half angles also as like this. Sine theta we know 3 sine theta minus 4 sine cube. So what is cos 2 theta formula, students, here? What is cos 2 theta? Cos 2 theta we have four formulas. Cos 2 theta minus sine square theta, 2 cos square theta minus 1, 1 minus 2 sine square theta, 1 minus tan square divided by 1 plus tan square, right? So cos cube theta we have four formulas. And what is cos 3 theta formula? 4 cos cube theta minus 3 cos theta, right? These are the formulas you have to remember, right? And some more formulas here. Let me write here. And trigonometric identities also. What are the trigonometric identities, students? Sin square theta plus cos square theta is equal to what? 1. You know the trigonometric identity. So 1 plus tan square theta is equal to secant square theta. 1 plus cot square theta is equal to cosec square theta. And some more important things here, right? With the help of these cos 2 theta, we'll be applying, we'll be having two more formulas like this here. These are very much important one. So 1 minus cos 2 theta. These are very much important one. Many times we are using this one here. What is 1 minus cos 2 theta here? 1 minus cos 2 theta. Just shift this one and this one. You shift the things here. What happens? 1 minus cos 2 theta is 2 sine square theta. Right? Similarly, 1 plus cos 2 theta is 2 cos square theta. With the help of cos 2 theta formula, we have obtained these two things there. Send minus 1 towards left side here. 1 plus cos 2 theta will be 2 cos square theta. So these two formulas are very much important. you can convert into half angles also. These can be converted into half angles. Instead of 2 theta, if we have only theta, so what we have to do now? We have to convert it as half angles. 2 sine square theta by 2. Half of 2 theta is theta. Similarly, theta is half is theta by 2 then, right? So 1 plus cos theta, how do you express? So 2 cos square theta by 2. Okay? Now, some more other things here, right? Sine of a plus b plus sine of a minus b is what here? 2 sine a cos b, right? Sine of a plus b minus sine of a minus b is 2 cos a sine b. Cos of a plus b plus cos of a minus b, right, is 2 cos a cos b. Cos of a minus a plus b minus cos of a minus b is what here? Minus 2 sin a sin b, right? And also some other 4 things. What are the other 4 things here? Sin c plus sin d, right? It is of like the same thing here. 2 sin c plus d by 2. Next cos c minus d by 2. Same as the above 4 things here, right? So instead of a plus b and a minus b, have c and d there, right? We have to replace a as c plus d by 2, b as c minus d by 2. So now similarly sin c minus sin d. 2 cos c plus d by 2 sin c minus d by 2. So cos c plus cos d is what now? 2 cos c plus d by 2 cos c minus d by 2. And last one, cos c minus cos d minus 2 sin c plus d by 2 sin c minus d by 2. Right? So these formulas, friends, to solve the third exercise problems, you need these formulas only, right? These formulas. If you remember these things, you can solve easily the integral of the third exercise. So please note down all these things here. You know all these things in the first PUC. We are going to implement for the third exercise. So you can pause the video and you can note it down. So let me start the third exercise problems. Exercise 7.3. Main heading you write on here. Find the integrals of the functions from 1 to 22. Right? The first one here. Sine square of 2x plus 5. Okay. So to solve these all the third exercise problems, you need the formulas which I have given 1 to 27 formulas. First 15 for the simple integration, that is for first exercise, and next from 16 to 27 formulas for the substitution method. We know these two ideas here, simple integral forms and substitution method. So now there are some other integrands we can convert into the second exercise problems as well as first exercise problems, right? You must have the idea of both the exercise problems, then only you can solve the other things. So now if you see the integrand here, if you see the integrand as like this, whatever it may be, consider it as I. I told you, whatever may be the question, consider it as I. So integral of sine square of 2x plus 5, right? So as we know, if we have only the sine x, right? If we have only the sine x, integration will be minus cos x. If we have only like this here, sine of ax plus b dx, we have the formula minus cos of ax plus b, right? Sin x integration is minus cos x. Now differentiation of inner function, differentiation of ax plus b is a, that we have to divide it. You know the things you come across in the substitution method, second exercise. But here we have sine square. Because of only single sine here, we can apply this form here. But we can't apply for this sine square as cos square there, right? It is totally wrong. So for the square terms, for the cube terms, for the to the power 4 to the power n, we have to convert these things as a sum of the two terms or difference of the two terms. So these are the integrand we haven't seen in the previous two exercises there. So for these things, what we have to do, we have to transform these things. We have to convert these things as a sum of the two terms or the difference of the two terms. How we can convert these things? With the help of these trigonometric formulas here. So how? Just see. It is very simple. I told you this formula here, this formula, right? These two formulas are very much important, I told you, right? If you focus on these things, 1 minus cos 2 theta is 2 sin square theta. 1 plus cos 2 theta is 2 cos square theta. So what I required here, sin square. Sin square is required means I will be using this formula here, right? I will be using this formula. So that you must know some of the trigonometric formulas, then only you can convert this sin square as difference of two terms there, right? And automatically you'll be getting the simpler integral formats. You can integrate it later, right? Now you see. So we know that, as we know that, what is 1 minus cos 2 theta here? 2 sin square theta. Yes or no? We know the formula, right? So I need only in the form of sin square there. So what I have to do? I should cross multiply 2 there. So what happens? 1 minus cos 2 theta divided by 2 is equal to what here? Sin square theta. Agree? So why am I doing like this? In the integrand we have sin square form. That's why I am doing like this here. Right? Instead of theta, what we have? Instead of theta, we have 2x plus 5. So convert these things in this format here. So what happened? Sin square, I will be replacing it as in this format. 1 minus cos 2 is there, you write on 2. 1 minus cos 2 theta. Instead of theta, what we have? Instead of theta, we have 2x plus 5. Carefully, you have to substitute it. Right? 1 minus cos 2 you write down. Instead of theta, what we have? Sin square theta is what here? 2x plus 5. Replace it. 4 divided by what now? 2. Why? Because for this formula, you write down the reason here. Mention the reason and replace it. Okay? Without mentioning the reason, if you write directly, they won't give the marks. Right? They think that you people are copied there. So mention the reason, okay? Dx, right? So now further you simplify the things. Further you simplify the things. You know how to simplify. Now, just see 1 minus, right? Cos. Multiply 2 inside the bracket. What happens? 2 into 2x, 4x plus 2 into 5 is 10. 4 divided by 2 dx. So 1 by 2 is constant. Take outside the integral sign, right? What remains here? 1 minus cos 4x plus 10, right? Dx. So 1 by 2 is constant, take outside the integral sign. Now you integrate it. You know the formulas here. You know the 27 list of formulas here. So now you can apply the integral here. Integration of 1. What is the integration of 1, students? It is x. Integration of 1 with respect to x is x. Minus is there, you write a minus here. So what is the integration of cos? What is the integration of cos, students? Plus sine. Derivative of cos is minus sine, but integration of cos is plus sine. Similarly, if you have like this, cos of ax plus b, so what would you do here? Same thing. Cos integration is sine integration. Sine answer. Cos integration is sine. So inner function is of linear form. Differentiated. Ax plus b differentiation is a. That you have to divide it here. You know this thing here. So same. It is similar to like this here. Cos of ax plus b form. So what is the cos x integration? Sin x plus sin x plus into minus again minus. Sin x is what now? 4x plus 10. Cos x integration is sin x. That 2 plus here. Plus into minus again minus. So divide by. So inner function I should differentiate. 4x plus 10 differentiation. 4x plus 10 differentiation is what here? 4 into 1 plus 0. That is 4. So that you have to divide here. You know the things. In the second exercise, I told you while deducing these type of formulas here. Right? So plus c. After the integration process, at last you should mention the plus c. Okay? Now, further you simplify. 1 by 2 into x is x by 2. Numerator into numerator, denominator into denominator. X by 2 minus 1 by 2 into this one here. 1 into sine of 4x plus 10 is same thing. Divided by 2 4s are 8 plus c. Right? So here directly we can't integrate. So that's why we use the trigonometric formula. We splitted this as difference of two terms there. So when you split as difference of two terms, you will be getting easily integrable integrands here, right? Then you can integrate with the help of formulas. You will be getting this as the answer. Got it? So you can write because here, right? Mention this formula because by this formula, right? We have applied cos x integration as sin x plus sin x. Here minus is there, plus into minus, minus minus. Easy, right? So only the thing you have to remember the formulas, trigonometric identities. So sometimes what you get when you apply the trigonometric identities, some of the integrands what you get in the form of substitution method. There also you can get as an integrand after applying trigonometric identities also. Here it is converted into the first exercise problem here, simpler form, right? So in some of the integrands, we will be getting again the little bit complex as the integrands there. There again you have to substitute the things. I told you these third exercise problems can be converted into second exercise and first exercise problems there, right? Based on the integrands, right? But in all the third exercise problems, we are using trigonometric identities compulsory there. Only the thing you have to practice it. Let us go with the second problem here. Sin 3x into cos 4x. Right? Sin 3x into cos 4x. So what I told you students here, if you have sin and cos, I told you that you have to substitute sin or cos as t there in the second exercise. But here they have given the same thing here, sin and cos. But here we can't substitute sin as t or cos as t here. Why? Because here the angles are not same. In the previous exercise, they have given like this here, right? Sin x into cos x like this, right? So we can substitute either sin as t or cos as t there. Why? We had same angle here, but in this case we do not have the same angle. But we can't substitute sin 3x as t there. You won't get this as a differentiable factor. So for these things, what we have to do? We have to go for the trigonometric formulas here. So whatever it may be considered as I now. right? Whatever it may be considered as an I here. So just see the integrand here. It looks like sin and cos. So which trigonometric formula I should use now? I should use this formula. You should remember all the formulas here. Sin of a plus b plus sin of a minus b is what here? 2 sin a cos b. 2 sin a cos b. Whether you know this one here, sin of a plus b plus sin of a minus b is 2 sin a cos b. See the integrand. Well, it looks like same thing here, sin a cos b. Here a and b are may be same, may not be same, but we do not have same things here. So it is 2 sin a cos b, right? It is in this format here. I do not want 2. So what we have to do? Cross multiply it. So what happens here? Sin of a plus b plus sin of a minus b whole divided by 2 is equal to what now? Sin a cos b. So we have taken in this integrand form by using the trigonometric formula. So now apply this sin a cos b in this format in the integrand. So what happens here? I is equal to integral of this. I am going to convert in this way here. Instead of a what we have? Instead of a what we have? 3x. Instead of b what we have? 4x. Apply here. So sin of a plus b. A is what now? 3x plus b is what now? 4x. Plus again in the middle we have plus rather plus sin of a minus b. Same thing. A is 3x minus b is what now? 4x. Whole divided by 2 according to this formula here with respect to x. So every time you should mention dx there, right? Compulsory with respect to x we are doing. Now let us simplify further here. Let us simplify further, students here. What happens? Sin, what is 3x plus 4x? Is 7x. Plus sin, what is 3x minus 4x? Is minus x. 1x, minus 1x, right? Whole divided by 2 dx. Got it now? Now you see, students here, 1 by 2 is constant, take outside the integral sign. 1 by 2 you take out the integral sign here. So inside what it remains here? Sin x. Plus is there, you add on plus. Plus is there in the middle, you add on plus now. Just see, what is sin of minus theta? I told you, what is sin of minus theta, students? Sin of minus theta is minus sin theta. Agree? So, sin of minus x will be what here? Minus sin x. I told you, whenever negative comes, you should put in the bracket. Right? So, sin of minus theta is minus sin theta. Middle plus sign as it is there. With respect to x. Now simplify further again. Plus into minus, minus it happens here. So I equal to 1 by 2 sin 7x plus into minus sin x. Now it has become easily integrable formats here. Right? You come across in the first exercise problems here. So now 1 by 2. Right? Now this 1 by 2 you should multiply both the things. So now we are integrating here. What is sin x integration, students? What is sin x integration? Minus cos x. Yes or no? Sin x integration is minus cos. Derivative of sin is plus cos, but integration is minus cos. So sin 7x integration is minus cos 7x. But inner function is of linear expression. Differentiate 7x. Differentiate 7x. Differentiation of 7x is what here? 7 into 1, that is 7. That you have to divide here. If you have the inner function as a linear form, that you differentiate it and divide it for the formula here. Integration of sin is minus cos and differentiation of 7x is 7, that you have to write in the denominator. Minus, keep minus as it is. Again you see, students, what is the integration of sin x, students? Integration of sin x is minus cos. Integration of sin x is minus cos. I told you, wherever minus comes, put in the bracket there. So now we have integrated both the terms. After integration process, at last you should mention the plus c. After the process of integration, close the bracket, plus c you should mention it. Okay, now further you simplify here. Further you simplify. Multiply inside here. Plus into minus, minus. 1 into cos 7x, 2 sevens are 14. Next you see students, minus into minus. Minus into minus, plus. Again, plus and plus is same here. So multiply inside here. Minus into minus plus cos x. I am multiplying inside here. 1 by 2 to cos x is cos x by 2. I'm writing directly here. Right? So 2 sevens are 14. 2 ones are 2. Right? Minus into minus plus I have written directly here. Plus c. So this is the answer. This is the answer. Got it now? So in this way you have to solve the problem. Just only you have to practice it. So for these type of product of three trigonometric ratios here. And third one, cos 2x, cos 4x, cos 6x. So we do not have any particular formula for these things, but we have to use the trigonometric identity for these all things here. So whatever may be the given question here, consider it as I cos 2x, cos 4x, cos 6x, right? So if you sort the given integrand in the descending order of angles here, trigonometric ratios, it is well and good to simplify further there. To avoid confusions like sin of minus as minus center, cos of minus as plus cos theta, to avoid all those confusions, you can sort here itself. You can sort out the given trigonometric ratios in the form of descending order angles here, right? Let me write in this way. Writing this way is same as writing cos 6x, cos 4x, cos 2x. I have made this integrand in this way, in the form of descending order of the given angles here, given trigonometric ratios here, right? Angles we have made in the descending format. So why you have done like this? You can apply the trigonometric ratios by taking this integrand there, but further while simplifying in this way you may get like this, sin of minus as minus sin theta. To avoid confusions like this, I am making in the descending format here, right? Now you see. Now which formula I should use now? Which formula I should use? We know that cos of a plus b. What is cos of a plus b plus cos of a minus b? What is the cos of a plus b and cos of a minus b, friends? 2 cos a cos b. So how do I come to know all these things? That's why we have to remember the trigonometric identities there. So I need cos a cos b here. So actually there are three things now. So first you apply for the first two things. Then again you can take the third one then. So it is looking like cos a cos b form. I do not want to, so send back to the left hand side there. So cos of a plus b plus cos of a minus b whole divided by 2 is equal to cos a cos b, right? So now apply this one here, cos a cos. For the first two terms you apply this one here. Keep the third term as it is, right? So this single quantity, cos A cos B, this single quantity is converted into sum of two quantities here, right? So now I equal to, what happens now? What happens? Integral of this, let me apply cos A cos B for the first two things here. So here A is cos x, B is 4x. Sorry, A is 6x, B is 4x. Apply in this way, cos A cos B in this way. So put in the bracket here, why? Because it is converting single term as a sum of two terms there. That's why we have to put in the bracket. So cos of a plus b. What is a now? 6x. Plus b is what now? 4x. plus again, plus is there again, cos of a minus b, plus cos of a minus b. A is what here? 6x minus 4x, right? Whole divided by 2. So for the first two terms, I have applied in this way here. Cos of a plus b, instead of a 6x, b we have 4x. Cos of a plus b plus cos of a minus b whole divided by 2, right? So one more trigonometric ratio is left out here. Which one here? Cos 2x. That you should multiply after the applying the formula here with respect to x. Got it? So this cos 2x multiplies both the terms. That's why we have substituted the bracket here. We have applied the formula, right? That's why we have substituted the bracket. Further, you simplify the things here. What happens? Cos, what is 6x plus 4x? It is 10x. Agree? Next, what is cos 6x minus 4x? Cos 2x whole divided by what now? 2. So this is multiplied with what here? Cos 2x. Right? So dx. It is a product, you see. It is looking like this here. Right? So what is it? It is nothing but 1 here. 2 into 1 is 2. Right? Denominator 2 into 1 is 2. So 1 by 2 you send back the out of the integral sign there. Right? It is a product. It is a product. It is nothing but 1 here. 2 ones are 2. So 1 by 2 you send out the integral sign there. Right? 1 by 2. Take constant outside. What remains here? Cos 10x plus cos 2x into cos 2x there. So these things are left out. The numerator I took here. Right? So now you see. Multiply again, once again here. Multiply once again. Cos 10x into cos 2x. Cos 10x into cos 2x. Plus cos 2x into cos 2x. Cos square 2x. Right? It becomes like this. So once again, I should apply this formula here. Once again, I am going to apply this formula. Cos of a plus b, cos of a minus b. Why? Just see this. The first integrand, it looks like in this format here, cos a cos b. Once again, I should apply this formula here. And for this one here, for this one, what I should apply? We know that 1 plus cos 2 theta. What is 1 plus cos 2 theta? 2 cos square theta. I need cos square theta, right? So I should send back to the LHS side. 1 plus cos 2 theta whole divided by 2 will be cos square theta. So for the second term, I should apply this formula. And for the first term, I should apply again this formula here. Now you write down it directly here. So I equal to 1 by 2 integral of. So for the first term in the bracket, for the first term, what is cos A cos B? Cos A cos B is in this format. Here A is 10x, B is 2x. Apply this formula, cos A cos B formula. So once again, I have not written here. Just you know this. I have already written once. Just apply it. So what happens now? Cos of A plus B. A plus B means 10x plus 2x. 10x plus 2x plus cos A minus B. 10x minus 2x. Right? So whole divided by 2. Whole divided by 2. This formula I have applied. So there is a plus in the middle. That one plus. So what is cos square theta now? Cos square theta I should apply in this way. 1 plus cos 2 theta. 1 plus cos 2 theta. 1 plus cos 2. What is theta here? Instead of theta, what we have? Cos square theta, right? Cos square theta. What is theta here? 2x. So 1 plus cos 2 into theta. Theta is what here? 2x. Carefully you should substitute here. Cos 2 theta. Theta is 2x now. Whole divided by 2. Okay. So with respect to x. Got it now? Now you see. Now you see here. Simplify the things in the integral, the bigger bracket. So simplify here. 10x plus 2x is 12x. What is 10x minus 2x? Is 8x. Whole divided by 2. Plus here 1 plus cos 2 into 2, 4x divided by 2 dx. Correct now? Take the LCM, students. Take the LCM. I'll be erasing this. Take the LCM. LCM will be 2. So 2 how much are 2? 1s are. 2 how much are 2? 1s are. Given numerator remains same then. So what happens here? Cos 12x, cos 8x plus same thing. Numerator remains same. 1 plus cos 4x dx. So you see 1 by 2 is constant. Take outside the integral here. 2 2s are 4. It happens here. So outside of the integral we will be getting 1 by 4. If you take outside 1 by 2 into 1 by 2 is 1 by 4. So what remains here? Cos 12x plus cos 8x cos 8x, right? 1 plus cos 4x. Now you know, now it has become the simple integral form. Now you know how to apply the integration of cos x. What is the integration of cos x, students? What is the integration of cos x? Is sin x. Integration of cos x is sin x. Derivative of cos x is minus sin. But integration cos x is plus sin. So now apply that. Apply that. So integration of cos x is sin x. Instead of x, what we have? 12x. Got it? Cos x integration is sin x. But inside the cos, we have the linear expression. Differentiate 12x here. Differentiate 12x is differentiation of 12x is 12. That you should write in the denominator. You know the things. Plus similarly, what is cos 8x differentiate integration? Cos 8x integration is sin 8x plus sin 8x. So now differentiation of 8x inner function 8 that you have to divide it. Next, one integration, students. What is the one integration? X. Next, cos 4x integration. What is cos x integration? Sin x. So that is cos 4x integration is sin 4x. But inside we have linear form. Differentiation of 4x is 4 that you have to write it. Right? So after integrating all the things, close the bracket, integrating all the things, at last you should mention the plus c. Do not write plus c inside the bracket. So close the bracket. At last you should mention the plus c. Got it? So now further you can simplify or else you can leave here itself. Furthermore you simplify here. Multiply 4 inside the things here. Denominator 4 here. What happens? 1 into sin 12x. Sin 12x. 4 12 4s are 48. Next 1 into sin 8x. Sin 8x. 8 4s are 32. Plus 1 by 4 into x is x by 4. Next 1 by 4 to this one. 1 into sin 4x, sin 4x. 4 4s are 16 plus c. So this is what we got the answer. Right? Sir, it is too lengthy, sir. Yes, we have the integrand of in this format itself. We can't do anything. We have to follow the steps itself. Right? So, and also all the third exercise problems are of 3 marks, right? That's why they will give the lengthy problem, right? So all the third exercise are of 3-mark problems. Okay, so we got the cos 6x, cos 2x, cos 4x, cos 6x dx. Its answer is like this. Got it now? You may feel it as lengthy, but all the problems are of 3 marks. Of course, it will be lengthy one, right? You can write down directly the steps here. In detail, I have solved here. You can write down directly the steps here. Directly, you can take 2 outside there. Directly, you can multiply that 6 plus 4 is 10 by the mentally, and again you multiply cos 2x. You can skip the step. You can go further. When you practice it, you will be skipping some of the steps. You can write directly there, right? You may feel it is lengthy. I have written in details there. That's why. Okay. So let me do other problems similar to this one here. Now fourth one, students, here, fourth one, sine cube, integrate sine cube of 2x plus 1. Sine cube of 2x plus 1. So whatever it may be the thing, consider it as I. Let I is equal to integral of sine cube of 2x plus 1 dx. Right? So this one you can solve in the 2 to 3 methods there. Right? By using that trigonometric formulas. Right? Just here we have, you can apply 2 to 3 methods, and if you apply the different method, you are getting the answers as different there. But all the answers are correct here, right? For this particular integrand, you can apply 2 to 3 methods. For 2 to 3 methods, you are getting different answers. All the 3 answers are correct there. But whereas in the differentiation, you will be getting only one answer, right? Whereas the integration, if you do the integration with the different methods, you may get different answers. All are correct there. But in the differentiation, you will be getting only one answer as a correct there. So now you see, I will be giving you idea of what are the other methods we can apply here. So see, now you see, it is a sine cube form. What is sine cube form? Which formula I should use? Which trigonometric formula I should use? We do not have directly the sine cube formula there. So I should use the trigonometric identity as like this. We know that what is sine 3 theta formula here? What is sine 3 theta formula, friends? 3 sine theta minus 4 sine cube theta. It's all right. We know this. In this we have sine cube there. In this we have sine cube. So I should extract sine cube. So what I should do? Shift this towards left side and sine theta as right side. So what happens? 4 sine cube theta as 3 sine theta minus, send this towards right side, sine 3 theta. So why I have shifted here? Because I need in the form of sine cube. That's why. So again, I do not want 4. Send back to the RHS side. So sine cube theta will be 3 sine theta minus sine 3 theta whole divided by 4. Got it? So now substitute this one into this, right? So I equal to, what happens? Sine cube theta, theta is 2x plus 1. Sine cube theta is written as, it's a sine cube to the power 3 there. It's a to the power 3, right? Don't think it has 3 theta, sine cube, right? It's sine cube, here will be sine cube. I shifted here, right? So now, what is sine cube here? Like this, apply it, is sine cube formula. 3 sine theta, sine, what is theta here? Theta is what here? Sine cube is x. Theta is what now? 2x plus 1 minus sine 3 theta. Theta, again theta is what? Sine cube theta. Theta is what here? 2x plus 1 whole divided by 4. Got it now? I use sine 3 theta formula. In the sine 3 theta, we have sine cube form. I extracted in this way. I applied sine cube theta as in this way here. 3 sine theta is 2x plus 1 minus sine 3. Again, theta is what here? 2x plus 1 whole divided by 4. Further, you simplify. 1 by 4 is constant. Take outside the integral sign there. Right? 3 stick with the first term. We can't take 3 outside. Just what remains here? What remains? 3 sine of 2x plus 1 minus, right? Minus sine, multiply 3 inside the bracket. 3 2s are 6 plus 3 1s are 3. Now it has become simple integrable format shape, right? So now integrate it here. Now integrate towards here. I equal to 1 by 4. Put the bigger bracket here. Now integration of 3 sine of this one here. 3 is constant, keep as it is. 3 is constant, keep as it is. What is the integration of sine x? Integration of sine x is minus cos x. I told you, minus is there means we should put in the bracket. Integration of sin x is minus cos x. Instead of x, what we have? 2x plus 1. Right? Sin integration minus cos. But inner function is what? Inner function is 2x plus 1. Differentiation of 2x plus 1. What is the differentiation of 2x plus 1? Is 2. So that you should divide here. That you should divide. Got it now? Integration of sin is minus cos, but inner function is linear expression. Differentiate and write down in the denominator. You know that rule here. Again, minus is there. Keep minus as it is. Again, what is the integration of sin, students? What is the integration of sin? Minus cos. Wherever minus you get, put in the bracket. Minus cos of 6x plus 3. Right? Sin integration is minus cos. Right? Divide by. Again, we have inner function as linear expression. Differentiate this. 6x plus 3 differentiation is what here? 6 into 1 plus 0. That is 6. That you should divide here. Got it? So after completion of integration process, got it? So we have applied what here? Integration of sin as minus cos. Right? Or else you can, we know this one here. Sin integration is minus cos of ax plus b, right? Differentiation of ax plus b is a. You know this. That's why we have applied like this here for this one, right? So now what happens? Simplify the things, you'll get in the answer. So I equal to 1 by 4. Simplify inside here. Plus into minus minus 3 cos of 2x plus 1 divided by 2. Minus into minus plus cos of 6x plus 3 divided by 6 plus c plus, oh sorry, firstly we should put the bracket, right? Firstly we should put the bracket and plus c write, right? Plus c write. Now again further you multiply inside here, what happens? I equal to 1 into this one, same thing, minus 3 cos of 2x plus 1. 4 2s are 8. If you keep this answer as it is, no problem. Further you can simplify here. Plus 1 into same thing here. Cos of 6x plus 3. 4 6 are 24. Right? So plus c. This 1 by 4 multiplies only for the two terms. Plus c as the answer last. So this is the answer for the given sin cube. Got it? So this is one of the answer for this one here. And you can go through the different method also, students. You can apply different method for this one also there. So how do you apply the different method? Just check it out here. You can do at home here. Whether you can solve in the free time there. You can solve this in another method here. Just see here. This can be written as like this: sin square 2x plus 1 into sin 2x plus 1. Can we write like this here? Can we write like this? Yes. So what is sin square formula? It is 1 minus cos square. Can we write? Right? This remaining term as it is. Sin square is written as 1 minus cos square. Yes. Now you can substitute. Now you can substitute cos 2x plus 1 as t. Now you can substitute cos 2x 1 as t. What is the differentiation of cos 2x 1 plus 1 here? So minus sin 2x plus 1, right, into 2, right? By the chain rule, 2x plus 1 differentiation is 2 is equal to dt by dx, right? You can cross multiply dx here. What happens here? Minus 2 sin 2x plus 1 dx is equal to dt. So now I do not want the negative terms, positive terms in the LHS side, so I should divide it. Divide minus 2 on both sides. What happens here? dt by minus 2. So these things we have to substitute in this one here. If you substitute in this one, what happens? 1 minus, I substitute it as t. It becomes t square, right? Sin 2x dx will be what here? dt by 2. Right? You know, we have converted into second exercise problem, students. Now integration of 1 is t, integration of t square is t cube by 3. You know how to solve further there, right? But you get different answer from this one here. So I have applied this sin 3 theta formula I got this as the answer. If you go in this method, you'll be getting different answer. That answer is also correct one. That answer is also of correct one. In the integration, you might get different answer. All the answers are correct one. If you apply different methods there, if you apply different methods, you are getting different answers. All those are correct one, right? But whereas in the differentiation way also, right? So I feel that this one is a much easier method. That's why I have done like this. You can go through in this way also there, right? This is the first method. You can apply in another method also, second method also. So now let us move with the fifth one. Let us move with the fifth problem. So we have to integrate this function here, sine cube x cos cube x. Sine cube x cos cube x. So I told you you can substitute sine differentiation as t or cos, sine as t or cos as t. Yes, of course, right? You can substitute here. Why? Because we have the same angle, right? That too, what we have to split the things there, right? So let me use using the trigonometric identities. I am doing fourth exercise, third exercise by using trigonometric identities. Let me use that one. You can solve with the help of substitution method also. I told you now. You can integrate the given integrand in the various methods, right? You will be getting various answers. Now let me use using the trigonometric identities here. So whatever it may be, considered as I x dx. We know that what is sine 2 theta formula, students? What is sine 2 theta formula? 2 sine theta cos theta. Agree? Yes or no? What is sine 2 theta? 2 sine theta cos theta. But I need sine cube cos cube, right? So cubing both sides. Cubing both sides. What happens? Sine cube 2 theta, 2 cube, sine cube theta, cos cube theta. Agree? Cubing both sides. What happens? Sine cube 2 theta, 2 cube, sine cube theta, cos cube. But I need only this one. I need only sine cube cos cube theta. So send back to the LHS side. What happens? Sine cube 2 theta divided by, what is 2 cube? 2 cube is 8. So what remains here? Sine cube theta cos cube theta. So I have used the trigonometric formula. Replace sine cube x and cos square x as what here? This one. Right? Apply this. So what happens? Right? Sine cube x, cos cube x, I have used this formula. We got like this here. Sine cube 2, sine cube 2, theta. What is theta now? Instead of theta, sine square theta, cos square theta. Instead of theta, what we have? X. Right? Sine cube 2x divided by 8. Got it? I hope you understood with the help of this formula. So 1 by 8 is constant. You take outside the integral sign. Take outside the integral sign, 1 by 8. Right? What happens? Sine cube 2x dx. Right? Sine cube 2x dx. Again, it reduced in the form of what here? Again, it reduced in the form of first problem or fourth problem. Again, it has become the fourth problem. What is the fourth problem, students? What sine cube theta they have given, right? What we have applied? Sine 3 theta formula. What is sine 3 theta formula, students? 3 sine theta minus 4 sine cube theta. I record sine cube again. Here we had sine cube and cos cube. We have converted into the single sine there. Now again you apply the sine theta formula. What is sine theta formula? In this we need sine cube there. So what happens now? Sine cube theta, you shift this thing. 4 sine cube theta, you shift this thing. Is equal to 3 sine theta. This one you send to the RHS side, sine theta. So again send back here. Sine cube theta is what here? 3 sine theta minus sine 3 theta whole divided by 4. Whole divided by 4. So now I is equal to what happens now 1 by 8 as it is integral of. So sine cube theta I will be replacing in this way here, right? Theta is what now 2x. Here theta is 2x here. So replace this one here 3 sine theta. Sorry, theta is what now? Theta is what now? Sine cube as like this. Theta is what now? 2x. Yes or no? Theta in place of theta is 2x minus sine 3 as it is again theta. What is theta here? What is theta? 2x. Right? Whole divided by 4. Got it now? So now 1 by 4 is constant. Take outside the integral sign. 8 4 is 32. So outside of the integral it will be what here? 1 by 32. Now so 3 sine 2x remains inside here minus sine 6x. Right? So 1 by 32. Now you know the integration formulas here. Integration formulas 3 as it is. What is the integration of sine 2x? What is the integration of sine 2x? Minus cos 2x. Integration of sine is minus cos. So minus cos 2x. Inner function is 2x. Differentiate that one. 2x differentiation is 2. That you have to write in the denominator. You know the things here. Right? Wherever minus is there, put the bracket. Minus. Again, sin x integration is minus cos. So minus is there, means put the bracket. So sine integration is cos 6x. Sin 6x integration is cos 6x. Again, inner function is linear form. Differentiated. 6x differentiation is 6. That you should divide here. So after the integration process, at last you should mention the plus c as an integral constant here. So put the bracket. After putting the bracket, you mention the plus c there. So further you simplify, you will be getting the answer. So what do you get the answer now? 1 by 32. So plus into minus. Minus 3 times cos 2x divided by 2. Minus into minus plus cos 6x divided by 6 plus c. So you can keep answer here itself, or else further you can do it. So further you can simplify here. Plus into minus 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 3 cos of 2x divided by 32 2s are 64. Plus into minus plus into plus. So 1 by 32 into this one here. So 1 into cos 6x is cos 6x in the numerator and the denominator 32 into 6. 6 2s are 12. 1 carry 6 is 18 plus 1 192. So plus c. If you multiply 1 by 32 into this 6, you will be getting 192 as the answer. So this is the total answer for the given sine cube cos cube there. So this is the one of the method you can do here, right? So I will be taking 2 more minutes to understand the second method for this problem here, right? So let me give you one more method for this problem. So consider it as I is what now? Sine cube x cos cube x dx, right? So I'll be splitting this as like this now. Cos cube I'll be splitting it as like this, cos square x into cos x dx, right? So why sir, why we do like this? As we know, sine differentiation is cos, right? So in that way, so in that manner, I split it in this way. So what I have to do now, as I know that cos square is 1 minus sine square. Yes or no? Cos square is 1 minus sine square. So remaining cos x as it is. Now you apply the second method forms here, that is substitution form. As you know, the sine differentiation is cos, so put sine x as t here. Right? Differentiate it, cos x. So differentiate with respect to x. What happens? Tan x differentiation cos x. T with respect to x is dt by dx. Cross multiply. So cos x dx is equal to dt. So apply these things where? In this one. Apply these things in the equation 1. So 1 implies what here? I equal to sin x. Sin x, what I substituted? T. It becomes what here? T cube. Got it? So bracket 1 minus sin x I substituted as t. It becomes t square here. Sin square. So cos x dx is a differentiable factor. What we get here? dt. Now it is reduced to the simple form, right? So further you integrate it. So this is the second method I am explaining you. So I equal to, in multiply inside here, t cube into 1 is t cube. T cube into minus t square is minus t raised to 5. A raised to m into a raised to n is a raised to m plus n. 3 plus 2 is 5. Right? So dt. So further you integrate here. Further you integrate. What is it? T raised to 3 integration. T raised to 3 plus 1 by 3 plus 1. X raised to n formula here. You must know all the things. T raised to 5 formula, t raised to 5 plus 1 by 5 plus 1. X raised to n formula. You know already, I have written directly. So what happens now? Replace back t as OD. Replace back t as OD as sin x. So what happens? Sin 3 plus 1 is 4. 4x. T is what now? Sin x. I am replacing back as a x here. Why? Because they asked in the form of with respect to x. So divided by 4 minus t is again what here? Sin x. 6 5 plus 1 is 6 divided by 6 plus c. Now you see students, when I applied the two methods here for the same integrand, I have solved in the two methods. For the first method, you got the answer as this one here, minus 3 cos 2x by 64 plus cos 6x by 192 plus c. For the second method, I got the answer in this way, sin raised to 4x by 4 minus sin 6x, sin raised to 6x by 6 plus c. So you feel that, so these two are, you may feel that, so one of the method is wrong here. No, both the methods are correct one and both the answers are also of correct one here. Right? Both answers are also of correct one. So in the integration problem, you may get, I told you, you may get various answers by using various methods there, right? By using various methods. But in the differentiation, we will be getting only one thing as the answer. In the integration, you may get different answers by using different methods. I told you many times here, right? So let us meet in the evening session to continue this third exercise problems here, right? So you may take down both the methods for the knowledge sake. Thank you. 1 minute.